For our third and final graph in 4.5 day 2, I want to show you how to graph a tangent when it's modified. So we've found out a couple of things about tangent and cotangent graphs in the previous examples, but I want to just do something here to sort of compact the whole process and make this a little easier to handle, and that we don't always have to go back to sines and cosines and all that sort of business. So I want to give you just some ideas as we get started here. Now I'm going to reference the graphs that we did for previous examples, previous videos, and I want you to notice a couple of things about these. So first one is a tangent graph that we did. And in this tangent graph, I want you to notice that there is a branch of the graph going directly down the middle. So this basically just cuts that period in half right here. For the cotangent graph, it's a little different. The vertical asymptotes are in a different location. The vertical asymptote, the first one, is actually right on the y-axis. That's a little bit different. But what I'm going to do just to shortcut certain things here is I'm going to give you a couple of key words to think about. For cotangent, I like to think about this one, since it's right up next to the axis, that first vertical asymptote. I like to refer to cotangent as adjacent to the axis. Okay, I like to refer to that as adjacent to the axis. That is for cotangent. For tangent, it's kind of right up the middle, and so what I like to refer to this one as is centered on the axis. So tangent is centered, and cotangent is adjacent to the axis. Depends on, we're talking just mainly about where those vertical asymptotes exist. And so I want you to be thinking about those two concepts when we look at this one here with tangent, 3 tangent of x over 2. Now first of all, we need to figure out the period. If we're going to figure out adjacent, centered, that kind of thing, the period is going to be kind of important for us to start with. So let's look at this x over 2. Now another way to think about that is that's like saying 1/2 x. So the 1/2 is our coefficient here. Now in the past, when we were talking sine and cosine, we did 2 pi divided by that coefficient to get the period. But remember that tangent and cotangent have a basic period of pi. So what we're going to do here is we are going to do pi divided by this coefficient, so divided by 1/2 in this case. It actually turns this one, this particular example, into a period of 2 pi. So if I've got 2 pi for this one, that helps me for one thing. It helps me to know how far I am between vertical asymptotes. The other thing I need to remember is that we talked about tangent as being centered over the axis. So the axis goes right through the middle, and I've got a vertical asymptote on either side. So I go halfway over onto the left, halfway over onto the right. So that means here, if my period is 2 pi, and I want to go half on the right, half on the left, that means the total distance, if I have it centered, is going to be between negative pi and pi. So this is where my asymptotes are going to have to be. So this is centered, and the reason I put them there is so that the total distance between that one and that one is going to be 2 pi. All right. Now, I don't have a whole lot of room left in the outside of this graph, and so I might need to expand it one way or another. You can certainly do that if you want, but on this graph, I'm just going to make up for it by doing 2 half periods, one on the left and one on the right. But let's take a look at the middle here, and let's see if we can graph the branch that is right up the middle. Now, like before, I'm going to have a point on my graph that is absolutely centered between those 2 vertical asymptotes. Then what I'm going to do is I'm going to choose a point that's halfway between the center and the side, which is right here. Now this happens to be pi over 2 in this instance. I need to plug in pi over 2 to my function up here and see what is it that comes out as the y value here. Now you guys, maybe some of you are noticing this 3, and what do I do with that 3? Well, that's the next thing I'm going to answer here. That 3, if you're thinking sine or cosine, you'd be looking at amplitude, but with tangent it's a little bit different from that. We're just going to ignore it until we actually plug this thing in, and it'll work itself out okay. So I'm going to come over here and plug that in. 3 tangent of pi over 2 divided by 2. Now I've mentioned that this thing here will always have something to do with pi over 4, and that's what's happening right here. Pi over 2 divided by 2 is the same thing as pi over 4. It reduces down to that. So this is the same thing as 3 tangent of pi over 4. Now, how did I get from there to there? Thinking about this as divided by 2, I could also think about it as that being divided by 2 over 1, so I multiply by the reciprocal to get pi over 4. If that's something that's giving you trouble, just that simplifying, let me know and we can talk through that in a little bit more detail. But then I have here 3 times tangent of pi over 4. Now from my previous example, remember that we found tangent of pi over 4 is equal to 1. So I'm not going to reinvent the wheel here. I know that tangent of pi over 4 from our previous work is equal to 1. The 3 is out in front, so I just do 3 times 1. That means my number here is 3. So over on this axis, I'm going to go up 3 and put my point right there. And that's one of those secondary points that I need for this branch of the graph. Because this tangent graph has symmetry, it has odd symmetry, I'm going to go on the other side and just do the negative version of that. That's right over here. And once I have those points, I can sketch my branch of that graph. So there's my first full period. To get my other my other full period, I think about this being the whole thing. This is actually the halfway point, and so if I'm sketching this part of the graph, it's actually going to be the down part. It's going to be over here, and then on this side, this is the center, and it's going to be the up part in this case. So this one goes over here. So now I do have 2 full periods if you put those 2 together. And like I said on the previous graphs, the last thing that I want you to do is to label this point just to illustrate the fact that you found out what that was by plugging it in and finding the x and the y value, that kind of thing. So that is pi over 2, 3 as our point there. And so that's the last label that I would need to see on your graph. So remember that with tangent graphs, they're centered, and then you just split the period. If it is a cotangent graph, then you start right on the axis, and then you just keep going with your period, having the vertical asymptotes a certain distance apart for that period.